All right, so yesterday we worked on this problem. I'm going to re-go through the thought process just to kind of refresh our memory on where we started. And then at the very end, I started mentioning how you would go about finding the two acute angles when you don't know them. That's the new thing that you guys don't know how to do yet. But let's just, again, talk through, of the three types of methods I have, Pythagorean theorem, special ratios, and SOHCAHTOA, why did I choose Pythagorean theorem here? Josh? Because you know two sides. Right. Okay? All right. So we did Pythagorean theorem. I'm going to go ahead and do it again so that we can just kind of make sure we understand where we're at. So for Pythagorean theorem, to find little a, we had set it up with our hypotenuse. Which one is our hypotenuse? 7. So we had set up 7 squared equals, I think I used x yesterday. I'm going to go ahead and use little a today. Why did I put little a today? Why are you supposed to do that? But why isn't that a b? Why isn't that little b? I talked to you guys through this on Tuesday, I think. Manasa? Because it's opposite from the angle big A. So remember, little a should be across from big A, little b should be across from big B, little c would be across from big C. So that's why I put that variable there that time. All right, so I'd have little a squared and then plus 6 squared. So that had given me 49 equals a squared plus 36. When I subtracted my 36, what did we get? 13. And then we knew that we would take the square root, and we can see that 13 doesn't have any numbers that divide into it. So we had ended up with a equals the square root of 13. All right. So now I have found a, and all that I have left to find, so I have all three sides, all that I have left to find now are big A and big B, the angles, right? So yesterday I was talking you guys through what would you do to find big A. So when you don't know the angles, you're going to have to use trigonometry if you don't know either of the angles. So remember I said to pick your angle that you want to work on. So yesterday I had chosen to work from angle A and set up a trig function with the two nicest values that you have for the sides, right? So what are your two nicest values that you have? 6 and 7. So using SOHCAHTOA, which combination do I have for the 6 and the 7 from angle A? Cosine? Because we've got from the angle, we've got the adjacent side 6 and the hypotenuse 7, right? So yeah, it would be, we're going to end up using the cosine. So my setup here is the cosine of, and usually we would put an angle degree there, but do we know the angle this time? No, we don't. So we'd put angle A equals, and then the ratio. So the ratio is adjacent, which is 6 over 7. All right, now this is different from what we've done in the past, because in the past, your unknown has been either an x value here or an x value here, right? And you would have, in the past, you've had an angle measure there. So when you used your calculator, you were able to punch into the calculator cosine of some angle that you knew, right, and get a value for that. Can you get a value for this on your calculator right now? Can you type in cosine of A? No. So this one is different. Your unknown is within the cosine this time, which means that we need to move the cosine and not take the 36 with it. So this was what I was mentioning yesterday, was that you can take this cosine bit without the angle and you can move it to this side if you put what on it? What did I say to put on it? A -1 power, right? That's what we write it. We actually call it the inverse sign, so it looks like a -1 power, but we read that as cosine inverse of, and then you would take that of the thing that was on this side. All right, now this is where yesterday I kind of left you guys and said, take a look at your calculators. We were down to the last minute, so I didn't really get to point it out too much to you guys. But now go ahead, take out your calculators, and find that cosine inverse. Okay, I'm going to walk around the room and make sure everyone has found the cosine inverse. When you found it, you're going to type in cosine inverse 6 divided by 7 and then end your parenthesis. All right? If your calculator doesn't open a parenthesis, you're going to want to put a parenthesis in there. All right? I'm going to calculate it and let you know what you should get, and then we'll come back and carry on in just a second.
Do you want us to...
Okay, so I walked around and it looks like you guys all got it. You should have gotten approximately 31 degrees, right? All right, now this is the only time that you get to use a rounded value to find another value. The only time. Okay? And it's only because there's really not much of a computation involved. So if angle A is 31 degrees, angle B should be 49 degrees, right? They need to add up to 90. That's the only time that you can use a rounded value to find the other angle measure. If you're finding sides, you should never use a rounded value. Okay?
Will this be on the test?
Yes. Yep. Yes.
Would it be 59, not 49?
Oh, did I add wrong? Yes. Thank you. Yeah, should add to 90, right? So 59. Yep. Sorry about that. All right. So just to kind of recap, when you are finding sides, will you ever use the inverse key to find a side? No. To find a side, you will always use just the regular sine, cosine, tangent. Okay? If you are finding an angle, then that's when you should use the inverse key. So if you're ever looking for an angle, then you're going to use inverse. Okay? Any questions on that? All right.